Hey folks, how's it going? This is Mr. Murray coming to you with a little video on arithmetic sequences. In this video, I'm going to kind of break down again for you and give you a little bit more practice on explicit and recursive rules for arithmetic sequences. It's definitely been a while since we talked about them. Real quick, I'm just going to remind you I do have an arithmetic sequences intro video. I'm going to go ahead and have something come up right now in the upper corner. Go ahead and take a look at that. And that video will also help you if you forget about how to do arithmetic sequences. That one's just a little bit more broken down, whereas this one I'm going to go hopefully a little bit faster. But there will be problems that kind of I'll give you a chance to kind of chime in on, and then ones where you'll try them and then you'll unpause and I'll work through them as well. Okay, so basically the idea behind arithmetic sequences is that it's a sequence of numbers. So it's a number that follows a particular pattern, and in this case we're always either adding or subtracting. So I think of it always in terms of adding. So either we're adding a positive number and we're going up, or maybe we're adding a negative number and we're going down. So we're adding -2 or subtracting 2. Okay, that's it. What an arithmetic sequence will do. Okay, so we'll always either go up or down by the same number. Okay, and so an arithmetic sequence, what we did is first we identified them, and then what we did is we started to write rules to describe them. And what we found is that when we wrote the explicit rules, and the explicit rules give you the term values if you know the term number. So for example, when you plug in 1 to our explicit rule, we get 1. When you plug in 2, we get 3. When you plug in 3, we get 5. 4, we get 7. 5, we get 9, and so on. What we found is that the explicit rules resembled a linear function. For this one, it would be f of n equals 2n minus 1. And this, as you see, is like a linear function where the common difference, this is called the common difference of 2, okay, is represented on the graph maybe by the slope, right? If this is slope-intercept form, right, the slope is that common difference. Okay, we also learned how to write explicit rules, and what explicit rules do is they are rather not explicit rules, recursive rules. We also learned to write recursive rules. So what recursive rules do is recursive rules tell you term values if you know other previous term values. So that is to say, if I know this term 2, it will help me get term 3. If I know term 3, it will help me get term 4. If I know term 4, it will help me get term 5, right? And so by using the rule of, okay, just go up by 2, if I know that I'm going up by 2, I can get term 6 by going back and adding 2. Then I can get term 7 by going back and adding 2, right? Then I get the next one by adding 2. So this is using the idea of a recursive rule. And with a recursive rule, you need to do two things. You need to tell me the first number. So in this case, it's 1. And then you need to tell me if I want to find out a term, how do I get it? By using, this is the current term. How do I get it? By using the previous term, right? Because remember, n represents the term number. So if this is a term, this is the term right before it, right? The previous term, right? If this is 3, and minus 1 is 2, right? And 2, right, is literally right before 3. So f of n minus 1 in this, f of n in this case rather, is equal to f of n minus 1. So to get any term, I go back to the previous term and I add 2. Okay? Now the recursive rule looks almost exactly the same every single time you write it. The only thing that ever changes is this number right here, because not all sequences start at 1, and this number right here, because not all sequences go up by 2. For example, if I want to do this right here, here's my explicit and recursive rule. So first, I know that it's going down by 2. 9, 7, 5, 3, 1, right? If I take any number and I want to get the next one, I can see that I'm going down by 2. So difference is negative 2. Okay? And then, let's say that I plug in 1. Well, what I get when I plug in 1 here is negative 2 times 1, which is negative 2. But what I need to have come out is 9. So what do I need to add to negative 2 in order to get 9? What I need to add is 11. Another way people write it is this. You take the first term and you add, in this case, I could subtract the common difference times n minus 1. These are two different ways to write the explicit rule, and they're exactly equal to each other. They mean the exact same thing. Okay? So I just thought I would show you both ways. Okay, the recursive rule, there's only one way to write it. For this one right here, the first term is 9, and every other term, to get every term, I go back to the last one, and I subtract 2. So if it's difficult for you to write the recursive rule, try to turn these things into words, right? See how I wrote it in math, but when I said it out loud, it was words, right? The first term is 9, right? Or you could say the value of the first term, right? And I know it's the value because I see f of, and I know it's the first term because it's 1, right? This is the value of the third term is 5, right? You have to be able to turn the expressions into words, because then it will make more sense when you write them out. So the value of the first term is 9. The value of any other term is the term right before it minus 2. And if you think about that, this is right. The first term is 9, and any other term, say I just point randomly at 3, is the term before it minus 2. Okay? And as with many things, what I hope that you can do is look for those patterns that come up. Finding the negative 2, looking at where the negative 2 comes up, thinking about the fact that the negative 2 comes up there just as the positive 2 comes up there. They come up in the exact same places. And try to use those patterns that we see over and over again to generalize and to make like rules that make sense to you and help you solve the problems. Because that's kind of like the bigger picture we're playing at here. When we get to the more difficult problems that are like beyond this course that we're getting ready for, we got to think about what kind of skills can we use that work no matter what kind of math I'm doing. And this is one of them, right? Looking for those common patterns and using them to make conclusions. All right. So I'm going to move on to some problems for us to try. So with this one, what I'm going to be doing is I'm going to be identifying the explicit and the recursive rules. I'll write the explicit rule both ways, and you only have to do one. So you do whatever one works best for you. So the first thing I'm going to do here is I'm going to identify two key pieces of information, the something term and the something something. I need the first term and I need the common difference. Okay, the first term is 2. The common difference is 6 because I'm going up. I bet you need to fix this. 2. Let's make this to go up by 6. Still in me. Let's make this a 3. So I'll make the first term. Fortunately, this wasn't a U try, right? I'll make the first term into a 3. And I'll make the difference then is not a 6. The difference is then a 5. Okay, because I'm going up by 5. All right. So explicit rule. First, because it's going up by 5, this is how my explicit rule is going to start. It's got to start with f of n equals 5n. because the 5 represents the fact that it's going up by 5. Now, when I plug in 1, right, these, remember, are the term numbers. These are the n's. So I'm plugging in 1, I get 3. I plug in 2, I get 8. I plug in 3, I get 13. I plug in 4, I get 18. So when I plug in 1, I'm supposed to get 3. But right, when I plug in 2, I'm supposed to get 8, etc. But when I actually plug in 1 right now, I get 5, right? Because 5 times 1 is 5. So what I'm going to do is I need to put in a -2 so that when I plug in 5, or rather when I plug in 1, I get 5 times 1, which is 5, minus 2, which is 3. Now look, what if I chose 2? 2 times 5 is 10, minus 2 is 8. 3 times 5 is 15, minus 2 is 13. The other way to write it is this. You start with your first term, and you add your common difference times n minus 1. Okay, the reason that the second rule basically works is because what's happening is I'm essentially shifting down the line a little bit. So instead of starting at term 0, so to speak, and here's, right, instead of going back, thinking about going down and getting to -2, right, instead of finding term 0, I'm just basing it around term 1. And if you think about it, when you plug in 1, you get 1 minus 1, which is 0. So 2 different ways, you get the exact same thing. And you can prove that actually even by distributing this and seeing that out. Except that's not supposed to be a 2. My apologies. That's supposed to be a 5. Okay? So I like this rule personally because this rule that I pointed to makes a little bit more sense in terms of seeing how the inputs and the outputs are connected. There's a little bit less memorization, but there's, on the other hand, there's more work that you have to do on your end to make sense of it. The formula, as you see, the biggest downside is you just focus on memorization like I just did there, and then you get that mixed up. Okay, the recursive rule looks like this. So the first term is 3, and every other term, you go back to the term before it, and what do? You're going to be adding 5. Okay? Okay, so please make sure you understood what I did there, because I'm going to go ahead in a couple seconds. I'm going to go on to the blue one. All right, so here, let's take a look. What's going on? So we got the blue one. First thing we're going to find is what 2 key pieces of information? The difference and the first term, right? So what are they? The difference is -8. 37 to 29 down by 8. 29 to 21 down by 8. 21 to 13 down by 8. Now, here's the trick. If you can't figure out what's going on here, well, look to another 2 numbers, right? I look at 29 and 21, and I see, oh, I've got the 2, so let's just worry about the 9 and the 1. Oh, that's a difference of 8. Because remember, with an arithmetic sequence, it's always going down by the same amount. So it doesn't matter which 2 consecutive terms, right? They're consecutive because they're one after another. It doesn't matter which 2 terms you use as long as they're right next to each other, right? So I'm just going to use the ones that's easiest for me to figure out. Okay? So let's start with the rules. Explicit. First, I'm going to write negative how many n? 8n. Now, when I plug in what, I get 37. When I plug in 1, right? So when I plug in 1, I get -8 plus b is 37. So when I solve that for b, I get b is 45 by adding 8. And to test that, let's plug in 3. If I plug in 3, I'm supposed to get 21. When I plug in 3, I get -24 plus 45, because -8 times 3 is 24, and that is 21. So that checks out. I know this is right. I know I've got a 100% correct answer. Alternatively, if you memorize the rule, first term, all right, and I would take plus -8 or just -8, either one. They mean the exact same thing. You really should write just -8, but either one is fine with me. Recursive rule. First thing I need to write is what? The common difference. Rather, the first term. Silly me. I had the right thing there. Then I need to write f of n equals f of n minus 1 minus 8. Okay? To get any term, you go back to the last one and you subtract 8, right? Any term is the last one minus 8, right? So term 4 is the last one minus 8. This is and when I say last, I kind of mean like the previous one, right? Okay? Let's make sure we clear that up and write 37. Okay, moving on down, just thinking about time here, I'm going to move on down, do the purple one. This one, so we want to find what two pieces of information first. The difference and the first term. The difference is 15. The first term is 17. So the explicit rule, we start off with 15n, then I plug in what, and I'm trying to get what? I plug in 1, I'm trying to get 17. I've got 15, so I need to add 2. Let's check my work. 15 times 3 is 45, plus 2 is 47. Great. Alternatively, I could write it how? I start with the first term, which is 17, and then I write plus 15 n minus 1. Okay, again, it doesn't matter which of the forms you use, but it's got to be one of those two. Okay. I apologize if I'm seeing any hearing any tones there. Okay, recursive rule. First, I do the first term, which is 17. Then how do I start off the next line? I write f of n equals f of n minus 1, and then I write plus 15. So hopefully you're starting to remember that this is like overlap. The recursive rule is difficult conceptually to understand, but if you look at how you do it, it's very straightforward to actually write it out once you can actually put together those pieces of information. All right, last one is going to be this one right here. So what do I do first? Find the difference and the first term. Difference is -12, and first term is 100. We're going down by 12. Minus 12, minus 12, minus 12, minus 12. So, explicit rule, I start off with -12, and if I plug in 1, I'm supposed to get 100. So if it helps, write it out. So -12 times 1 is -12, plus that b value, whatever we want to call it, is 100. So therefore b is equal to 112, right, by adding 12 on both sides. All right, to get b alone. We can do that. Or what's the other way? 100 minus 12 or plus -12 times n minus 1. Okay, recursive, what do we write first? Okay, the first term, and then we write f of n equals f of n minus 1 minus 12. All right, so hopefully that all made sense to you. If you need to, go ahead and rewind and totally watch anything I've done so far. And then when you're ready, I'm going to move on for some ones for you to do on your own. Alrighty, so here's ones for you to try. So I've got these 4 sequences for which I need you to find explicit and recursive rules. So what you need to do is think about what we just talked about. You need to find that key information, those two pieces of information, and then in any form you want, write the explicit rule. As long as it's a valid rule, that's fine with me. And then write the recursive rule using the method we talked about. All right, so we'll pause the video. We'll try to do these four, and then when you're ready, unpause, and I'll show you what I got. All right, let's take a look at it. So the first one, we identify first we want to find the difference. So we're going down by 7. Okay, and I notice I use -1 and -8 personally. I thought that was easier. First term is 6. So I write f of n equals -7n. When I plug in 1, I need to have 6. Right? So when I plug in 1, I get -7. So I need to have 13. The other way to do it is, think about it. If I'm going down by 7 to the right, I'm going up by 7 to the left, right? I'm doing the opposite. So you can imagine this term 0 of 13, and that's another way to find that value. Just undo the sequence one time. So that's how the idea of recursion actually helps you out a lot there. Or you could write f of n equals 6 minus 7 times n minus 1. Recursive rule, f of 1 equals 6, f of n equals f of n minus 1 minus 7. Okay. Moving on to the blue. In the blue, I see I'm going up by 22. 22 plus 7 is 29. And then plus another 22 is 51, and then 73. And the first term is 7. Okay, so this is what I was saying before. Think about it like this. If I'm going up 22. So then if I go this way, I'm going to go down by 22, right? Because that's the opposite. If I go in the opposite direction, I do the opposite thing. So I'll go down by 22, I'm at -15. Think about it right here, right? I go down by 22, I'm at 51. I go down by 22. So if you use that idea of doing and undoing, you find that term 0. So you get f of n equals 22n minus 15, or you plug in 1 and you realize that to get 7, you're going to need to subtract 15, or you're at f of n equals 7 plus 22 times m minus 1. Okay, recursive, first term is 7, term n equals the previous one plus 22. Okay, last one. Whoa, oh, second to last one. Whoa. So I see going up by 35, it looks like. 77, 82, 92, 102, 112. Yeah, it looks like I'm going up by 35. Looks like I've got a first term of 112. So I've got f of n equals 35n. See, the 112 sometimes gets you confused. Now, when I plug in 1, I get 35. So what do I need to add to 35 to get 112? So I go to my calculator. I do 112 minus 35. I got 77. I mean, I think that's something you could do on paper as well. Okay, now let's check my work. If I plug in 3, I'm supposed to get 182. So 35 times 3 is 105, plus 77 is 182. Nice. Or I use the m minus 1 thing. 112 plus 35 times m minus 1. Recursive rule, I start with my f of 1, and then I do my f of n is the previous one plus 35. All right, here we go with the last one. So this one's kind of tricky. Here it looks like it's going up because you see like 20, 123, 226, 329. So you might be tempted to think, oh, it's going up by 103. right? But it's actually going down by 103 because it's actually decreasing by 103. It's getting more negative. Okay, so that is where that one gets tricky. And the fact that it's negative in general. So f of n, so we start with negative 103n. Then when I plug in 1, I get 103. So I need to know, what do I need to add to 103 to get 20? So I just add 103 on each side, negative 20 plus 103. And what I get is I get 83. So I put my 83 in here, or I write f of n equals negative 20 minus 103 times n minus 1. So seems easier. But again, if you don't memorize it, you flip the order around. You don't remember, you put the thing in the any kinds of things you mess up with the memorization of the order and everything, that all messes up the final answer. So that's why I'm trying to get at these ideas of plugging stuff in and trying to get things to work, because that idea comes up over and over and over with different types of functions. So that way you learn one overall idea that helps you with multiple things, instead of just learning this n minus 1 trick that only helps you with this specific concepts. Okay? Now, recursive rule, f of 1 equals negative 20, and every other term is the term before it minus 103. Okay, so hopefully you found this video to be helpful. This is just meant to kind of recap explicit and recursive rules of arithmetic sequences. Remember, we're now moving into geometric sequences where we're doing the operation of multiplying or dividing. Okay, so it's going to be really important for you to understand some of the overlaps, and so that's why I've taken time to put in a little bit more content and a little bit more practice here. All right, so keep it up. Best of luck. I'm looking forward to seeing your great work for this week. Don't forget to love math, and remember, you can do it. All right, thanks much. Have a wonderful day, and I'll see you next time.